Students, we were discussing the numericals from your section waves, okay, and we have just started to do this numerical. Let's continue that, okay, and finish its respective parts. So, I'm just repeating in short what we were doing in this last step, okay, that is find the displacement from the position of equilibrium, the velocity and the acceleration of a point 10 meters away from the source of oscillation. Alright, so students, since the value of x is given in this particular last statement, that is your x equals to 10 meter, so I have framed the equation of oscillation of the particular point, which is resembling as your a sine within bracket omega t minus 2 pi x by lambda. Okay, because x values is given and lambda's value is also 20 given on top of the calculation. Okay, so let's reduce it and let's see what is coming. So this will remain same, 10 into 10 to the power minus 2 sine 20 pi t minus, this will get cancelled and you will left with only pi. Okay, and this is in terms of meter. Clear? Now what is the question asked in part A? Repeating it again. Find the displacement from the position of equilibrium, the velocity and the acceleration of a point 10 meters away from the source, that we have done, for a moment t equals to 3 seconds. See, on the top I have written 3 t equals to 3 seconds. Alright, so let's write part A at t equals to 3 seconds. The displacement of a point will be y equals to, just students, we will follow this equation, isn't it? Because this equation we have calculated keeping all those data in our mind, keeping all those data in the calculation part. So yes, now I can consider this equation as the equation of my present sum, isn't it? So students, whatever data we will put, that means your t equals to 3 seconds, we will put in this particular equation, isn't it? Okay, let's see. So 20 pi, instead of writing t, what will I write? Into 3 seconds, that means into 3 minus pi. Okay, so just reduce it, just do the calculation. So this will become 60 pi minus pi, that means you're 59 pi. Okay, now students, if you just recall your maths classes, okay, what is the value of sine pi? That means sine 180 degree. Its value is 0, isn't it? So here, although my equation is y equals to 10 into 10 to the power minus 2 sine 59 pi, so this will be equals to 0, isn't it? Because 0 into anything will give you 0. So my this equation will be 0. Okay. Yes. So my part A is done. Let's move on to part B. What is the next question given, students? That this your part A was your find the displacement from the position of the equilibrium. So yes, you have done this displacement equation and you have calculated the required displacement for this sum. Now let's the second question is you have to find out the velocity also. Okay, so let's go to the part B. Okay, so students, you must have learned the equation or the formula for finding the velocity, isn't it? Again, I will tell you, students, go through all those particle relation between the particle velocity and the wave velocity, where we have done the derivation also. So I'm taking one formula from there, that is v equals to omega root a square minus y square. Okay, You can ask me that why I have chosen this formula. That means v equals to omega root a square minus y square. I have chosen this because my object is to find out this value of v, the velocity that is given in the question. Just read it once again. Okay. So see, in this particular equation, that is the original equation that you have read in your theory, I will get the omega's value. See, omega's value I have calculated on top. That omega's value I will get. And what is the next one? A. It is your amplitude part. Yes, I am getting from this equation, main equation that is given in the question itself. Yes. And the next part is your y part. Y part, yes, also I've just calculated right now in part A. So yes, all the parameters values I'm getting. Okay. So let's do the calculation. Omega is 20 pi. See, on top I've written omega is to 20 pi. Root a square will be what? This one, 10 into 10 to the power minus 2 whole square, isn't it? Minus y's value is 0, so I've written it 0. Okay, now let's do the calculation. So 20 pi, this root you are having and square also you are having, so you will just get only this 10 into 10 to the power minus 2. Okay, understood? Just think of the maths classes. Okay, this is my A part, amplitude part. See, my amplitude part is written on top in the main equation. Alright, so just calculate it. You will get, students, if you just do this calculation in your calculator, you will get as 6.28 meter per second. Alright, so student, my part B is also done. Alright, now I will find out the last part of the question, that is my acceleration. Okay, and all the data are remaining same, that is acceleration of a point 10 meters away from the source of oscillation for a moment t equals to 3 seconds. Alright, so students, the easiest formula or the main formula for finding out the acceleration is what? A equals to A equals to omega square y, isn't it?